All right, here we go. Question. Listen up. How many solutions is this equation going to have?
Multiple.
One. You subtract 1, divide by 2, that gives you what x is, right? How many solutions will this equation have?
One.
Okay, if x, let's say x,
Two, because X is
let's say x was 1, that would be 2 times 1 is 2. 2 plus what equals 4? Y would be 2. Okay, that's one solution. What if x were 2? Whoops. What could y be?
0.
0. Okay, that's another solution. How many solutions is this going to have? Infinite solutions. Every different x value you use, you're going to get a different y value to go with it to add up to 4. What's the difference between these two equations?
There's more.
The bottom one has more variables and the top
Right.
one has more constants.
The bottom equation has two variables. Two variables has an infinite number of equations. We've been using two variable equations and we've been graphing them, and they look like, so far, they look like a line, right, when we graphed it? Why does it look like a line? Because a line is infinite. Each of these dots represents a solution. 2, 0, 1, 2, that kind of stuff. So there's an infinite number of solutions. This only has one solution. X is 1. If you solve this, you get x is 1. I guess you could graph that on the number line. 0, 1, 2, dot. That's the graph of that. We didn't graph these though. Okay. This chapter is about a system of equations. So instead of just one two-variable equation, it's going to be two two-variable equations.
Right.
So, for example, 2x plus. Now let me write this differently. Hold on. Okay. So, how many solutions does this equation have?
Multiple.
Nope. Infinite. How many solutions does this equation have? Infinite. Like if I make x1, I get negative 1 for y. If I make x2, I get 0 for y. If I make 3, 1. Those are all solutions. Okay, infinite, infinite. How many solutions do you think they will have in common?
Maybe.
1. Okay, let's find out. All right, let's use the graphing. You guys, this is one of the questions that pretty much everybody got right on the test. Graphing the line. I guess because we just finished that chapter, it was fresh in your brain. All right, how do I graph this? Y equals 2x minus 3. Down 3, and then what do I do?
2 over 1.
Up 2 over 1, up 2 over 1, up 2 over 1. There's 1. So everything on this line is a solution for this equation. How do I graph this one?
Minus
Down,
2.
down.
Down 2, then where did I go?
And then up 1 over 1.
Up 1 over 1. My graph's not very neat. I probably should have been neater. These graphs both had a point right there if I would have graphed it neatly. What do you think that point represents? The solution for what?
This problem.
Okay, every point on this line is a solution for this equation. Every point on this line is a solution for this equation.
So the solution they have in common.
So this is the solution they have in common. So if you said one common solution, you were correct. So even though this has an infinite number of solutions, all these, this has an infinite number of solutions, all those, they have one solution in common at 1, negative 1. That's where they meet at. My picture's not very neat, but you guys can't.
Basically, if they're not parallel,
So-
they have one solution in common.
Right. How is this related to this? If you plug it in,
It's
makes a true statement. It's a solution. And same thing for this one. If I plug in 1 for x, I get 2 times 1 is 2 minus 3 is negative 1. That's the y value. If I plug in 1 for x, 1 minus 2 is negative 1, the y value. So if I plug them in, it's true for both. It's a solution for both. On the graph, it looks like where the lines cross. And this is what we're doing today, basically. That's why I gave you guys the graph paper. So we're good. Since we did well on the test on drawing lines, we should do well today. This is not really a graphing chapter, but the first lesson is. Yeah.
So is this just pretty much solving graphs?
It's graphing mostly, yes, today.
Okay.
We are on page 281. Actually, don't start graphing until 15. We're doing 281, 1 through 22. I already wrote it on the board up here. You don't start graphing until number 15. If you want to use your graph paper to write 1 through 14 down, that's fine. Or you can use 2 different pieces of paper.
Yes.
Whoops. Magic.
Whoa.
Wait,
1 through 22.
why does it keep it this and?
Oh, you didn't? Somebody put one behind on Brandon's. Right behind you. I think. Alright. Are we ready for number 1?
Are we doing odds here?
Odds together. Identify the solution to each system from the graph. If the solution, okay, actually I forgot the 2 weird cases. Usually 2 lines cross at one point, right?
Correct.
But what else can happen?
They can overlap.
Cross at a coordinate, right?
Okay, they could be parallel.
And there's no solution.
Okay, that means they would have the equations would have no common solution. So if they're parallel, there is no solution. There's something else that could happen.
They could like
They could be
One
the
on top of
the same line. Like that red line and this blue, they're the same line and they have all the solutions in common. So the book just wants you to put the equation of the line because that represents all the solutions. There's an infinite number of solutions that are described by the equation. We'll just write the equation of the line. Okay.
It's like arteries and veins.
Number 1, what is the common solution?
point where they just
5 over 1.
Close. It's not 1 over 5.
5 over 1.
It's,
Negative
1 over 1.
okay, it's not a fraction, it's a point on the graph.
4 comma
1, 5. 1, 5 is where those 2 lines meet at.
1 point. 1.
1 comma 5, it's a point on the graph. It's the x and y. If they had the equations written out, it would be the x and y that would work in the equation. 1, 5, yes. Number 3.
Negative 4.
No, number 3.
Oh.
No solution. How do I write that? A 0 with a slash through it. Okay, what do you guys think is going on in number 4?
all.
Solution.
So we write
Okay.
the equation.
Well, not everything works, but everything that works on one line works on the other line. So it's not really everything
All
works.
the points are on
So what we're going to do for that one is just write the equation of the line itself. So everything that works in the equation works.
What is the equation?
Okay,
Rises 1 over. Wait.
What is the
rises 2
slope?
over 1.
let's start with the slope on number 4,
2 over 1.
which is 2, right? So y equals 2x. What is the y-intercept?
Negative 3.
Yeah, negative 3. Okay, minus 3. So that would just, for number 4, that just represents all the solutions that both lines have in common. You can't list all the solutions because they're infinite, right? So you just write the equation that represents the solution. All right. So 3 and 4 are the two weird ones. Almost always it'll be like 1 and 2. 3 and 4 are the weird exceptions. Okay, number 6 or 5. Determine whether negative 2, 5 is a solution to each system. What do you think they mean on that one?
Right, yes
Plug
or
it
no?
in. Plug it in.
Plug it in. Do you think it has to work for both of them or just one of them?
Both
Both.
of them.
If it works for both, the answer is yes. If it doesn't work for one of them, you gotta put no. What?
Which one is for Y and which one is for X?
Okay,
Oh, the first one's X.
right, alphabetical order. X then Y.
A lot easier.
So on 5 we have X plus Y. Negative 2 plus 5, does that equal 3?
Yes.
Yes.
Okay. Second line. 2 times
Negative.
negative 2 is negative 4 plus 5, does that equal 1?
Yes.
Yes, so number 5 is just yes. Okay, I don't think I'm going to do all these odds with you because that's a little too repetitive. But let's jump down to number 9. Leave space, like one line for each, jump down to number 9. It's really the same thing. For each system, determine whether the given ordered pair is a solution. So we're just using a different ordered pair than the previous. It's really the same thing. Number 9 is 2 negative 5 the solution. So if you plug in 2, you get 2 plus 3 times negative 5. If you plug in the X and the Y, the question is, does that equal 13? What's 3 times negative 5?
Negative 15.
What's negative 15 plus 2? Negative 13. Is that what it's supposed to equal?
No.
So this one is not a solution. That's number 9. Okay, now jump to 15. This is graph paper.
Uh,
Um, all right, where should I start on 15? Y equals negative x plus 5. Where do I start? Up 5. 1, 2, 3, 4, 5. Okay, it's kind of important to be neat on these because where the lines cross is your answer. So if you're all over, if you're wild, you might not know what's going on. You get the wrong answer. Where do I go from there? Y equals negative x plus 5. Where do I go from there? Down 1.
To the right.
Okay. If there's no number in front of the x, it's a 1 or 1 over 1. So I go down 1, right 1. Down 1, right 1. You can go forever like that. Okay, again, try to be kind of neat. I may be in too big of a hurry here. Where do I start for the other line?
Negative 1.
Down 1. Where do I go from there?
Up 1 over 1.
Up 1, right 1, up 1, right 1, up 1, right 1. Am I done?
Yes.
No. What am I missing?
Yes.
Oh,
You guys.
I'm missing the answer. I am going to give you credit for drawing the graph like a point, but also you get a point for the right answer.
3 over 2 up.
3, 2. Okay, it's not a slope. By the way, the slope on this first line was negative 1, not negative 1x. Negative 1 is the slope. Okay, anyway, 3, 2 is the answer. The graph is basically just the work.
Do that. That's 2.
Okay, 17. Where do I start?
7 up.
Up 7. It's the very top of my graph. Make sure you make your graph 7 tall. Where do I go from there?
Down 6 over right 1.
Down 6, right 1. Down 6, right 1. So something like that. Pretty steep. Y equals 1. What does that look like?
You start at 0.
Huh?
Wait. Oh, never mind.
How did we graph y equals 1?
You have 1 in a draft string.
Go where? Say again?
1 in a draft string.
1 where?
1.
Right. Go 1, go up to 1 on the y-axis and draw a horizontal line. All these have a, whoa, that's way off. All these points on this horizontal line have a y value of 1. That's why it's called y equals 1. I notice on 18 it says x equals -2. So you go to -2 on the x-axis and draw a vertical line. Anyways, where did they cross at?
1.
1, 1. Okay, 19, what's different about 19?
This line 1.
It's in, what form is it written in?
Standard.
Standard. And we don't like standard, we prefer,
Normal.
Wait,
no, what's it called?
Y intersection.
Slope intercept.
Slope intercept form.
Alright, so what do I do?
make it, slope initial.
By doing what?
Subtracting 1, right?
Nope, y stays still,
No, subtracting x.
subtract 4x. This one, we did not do that well on the test. Y equals -4x plus 7. Kinda like the last one, go up 7. And go down 4 and over 1. 1, 2, 3, 4. 1, 2, 3, 4. The other one is x minus 3y equals 18. What do I do for that? Trying to get y by itself, so what do I do? Subtract the x. I'm going to put -x in front of plus 18. And what do I do? Yeah. Yeah, we did not get this one right in the test very often. So the 3's go way over here. We get y equals negative divided by negative is a positive. If there's no number right there, there's a 1 missing. Positive 1/3 x minus 6. Down 6. Then where do I go?
Where do you go? Up 1/3.
Up 1/3. Should hit your line already. Right? I didn't draw mine very straight, so I had to fix it a little bit.
Yeah, hit mine. Okay, neat.
Where do they meet? 1, 2, 3, 1, 2, 3, 4, 5. Right 3, down 5.
Oh.
Alright,
Wait, just roll through the back.
one more.
One more. Okay.
Let's see, x minus x plus 2y equals 10. Why don't you guys try it on your own and we'll check it in a minute, see if you got it right. Try it on your own first.
Yes.
slope reduces, you should reduce it, yeah. You don't have to, you'll still get the right answer, but I think it'll make it a little bit easier. Well, the y-intercept reduces to -3, which, yeah, you do need to reduce that. 6 divided by 2 is 3. Alright, I kind of made a mess, but there's my first line and there's my second line.
I'm gonna do the wrong one. I did 22.
Okay, so get blue out. I'm gonna start up 5, 1, 2, 3, 4, 5. I'm gonna go, where am I gonna go? With -1/2 slope.
One over 2.
Down 1, right 2. Down 1, right 2. Back there somewhere. I hope my answer is gonna be on the right side of the page, otherwise we're in trouble. We might be in trouble.
Uh-oh.
Okay, we're gonna start down 3. And you're gonna go down 9, right 2. Okay, that's not gonna work, so I'm gonna go backwards. Instead of down 9 and right 2, what am I gonna do?
Up 9.
Up 9 and back 2. Did I copy that right? I did. Up 9 and back 2. 1, 2, 3, 4, 5, 6, 8, 9, 1, 2. What a coincidence.
Wow.
You meet at that point right there.
What are the odds? Two, six.
What is the answer?
2,
-2,
6.
6.
Why is it a positive 6?
Because you go left 2, that's -2, and up 6.
No, I said 6.
Mr. Jordan, but isn't it rise over
You're trying to blame other
Rise over
people.
on the slope, which we're not, when we graphed it, we used the slope, but our answer is not a slope. It's just a point on the line.
So,
You're going to punish for you, too. You're copying people?
yeah.
Alright, try those evens. If you want me to check them, I'll come around.
Oh, and you